Alright, welcome to Area of a Regular Polygon, Level 4, and in this video I'm simply going to do one example where we put together everything that we learned levels 1, 2, and 3, and this should really come together very nicely and smoothly. If you haven't seen videos for level 1, 2, or 3, I highly suggest you go back and watch those. Otherwise, a lot of this might not make sense. Now, going back to our level 1 video, we know that if we have the area of a regular polygon, it will follow this formula: 1/2 times the apothem times the perimeter. Now you might be asking yourself, what is the apothem? The apothem is where we go from the center and we would drop straight down to our base, and it's always going to split our base evenly into two different things. I'll use one solid line there, and in order to make this formula work, we have to know what the apothem is. And so it's a little bit tricky to find. Now let's go ahead and see what we know before we get anything started. We have our area of our polygon is equal to 1/2 the apothem, which we don't know right now, times our perimeter, but we can find that. So we know that our perimeter is, each side is 7. So I'll say my perimeter is equal to the side length, 7, times, well, we have 1, 2, 3, 4, 5, 6 sides here. And what is 7 times 6? Well, that's going to give us 42 centimeters, and that will be our perimeter, 42. So now at this point, the only thing that we're missing is the apothem. Now let me go ahead and erase this because I want to make this really nice and neat so we don't get lost. And I'm also going to erase the apothem that I drew here just because I don't like to draw it right off the bat. So let me go back to my markers. And we're going to draw our center. And now I want you to think back to our level 2 video. Well, what's our first step? We always want to take our polygon and we want to divide it into an equal number of triangles, correct? And we'll draw our triangles from our center to our vertex. We call this the radius, center to the vertex. And if our polygon has 6 sides, well, then we're going to have an equivalent number of triangles. So we should have 6 triangles. Let's see, 1, 2, 3, 4, 5, 6. Yes, that's correct. And we know that if we took all of our central angles and put them together, it would create a circle, which is how many degrees? Right, that's going to be 360 degrees. And we'll divide that by the number of sides of our polygon, or the number of triangles, which in this case is 6. And so I'll do 360 degrees divided by 6, which is 60 degrees. And I can go ahead and write that right there. That's 60 degrees. Right there, 60 degrees and 60 degrees. Now at this point, we have enough information to draw our apothem and create our right triangle. So let me go draw a nice yellow, and I'll drop my apothem. Once again, it goes from the center to the midpoint of our base, and it splits that line into 2 congruent pieces. I'll draw one piece right there, and if you'll notice, when we draw that apothem, it creates a right triangle. Now that's what I'm going to draw. I'm going to draw my right triangle right here. So I draw my right triangle, and we know that if this side is 7, well, our apothem, what does it do? It cuts everything in half. And so I can do 7 divided by 2, which is going to be 3.5. And so I know that this base right here is 3.5 centimeters. I'm trying to find this length, which is my apothem. And now I can actually find this angle. We know the apothem, it cuts everything in half. And so I'll take my 60 degrees and divide that by 2 as well. And it turns out this top angle is 30 degrees. Now I hope you have all this written down. If you need to, go ahead and pause the video. But I'm going to go ahead and erase everything I have here on this left side. So I'm going to erase all of this, because I want to give myself space to really write this out very nicely and neatly so that you do not get confused. And what we're really doing here, going back to our level 2 video, is we're just trying to draw that right triangle, because using that in one of our trigonometric functions, we can actually find out what is the length of the apothem. Okay, so let's see, going back to my pen. So I want to find this value right here, and we know this side touches the angle, so this must be my adjacent. And we know that this side right here does not touch the angle, so that must be my opposite. And there's one function we're always going to use when we're given the base and we're trying to find the apothem, and that one function is this. It is the tangent theta, which is equal to the opposite over the adjacent. Let me complete that A. So we know that when we have tangent, our theta is always going to be our angle. So we have tangent of 30 degrees is equal to, and we said our opposite was going to be 3.5 over our adjacent, which is x. Now, whenever we have these trigonometric functions and our variable is on the right-hand side in that fraction, we're always going to multiply by the bottom of the fraction or the denominator. So here I'm going to multiply this right side times x, and these two things will cancel out. And remember, whatever I do to the right, well, I have to do to the left. And so now we have this. We have the x tangent of 30 degrees is equal to 3.5. And you're always asking yourself, is our x by itself? Well, in this case, no, it's not. And so we're going to divide this left side by the tangent of 30 degrees divided by the tangent of 30 degrees. And this will actually give us x equals, and let me go back to my calculator. And let's see. So we're going to say this. We have 3.5 divided by the tangent of 30 degrees, and that's going to equal 6.06. Let me make that 30 look more like a 30. Okay, so we found this x value. Now here's what happens. A lot of people find this x value and you do all the math correctly, but you forget what you're looking for. Well, remember, what we just found was the apothem. Okay? We just found this length right here. So let me go ahead and once again pull up my eraser. And we can erase this little blank right here because we actually know the apothem. And in this case, it's this 6.06 that we found. Now, let me go ahead and erase my right triangle. I hope you have that drawn. Erase, erase, erase. And going back to my red to keep consistent, we're going to say that the area of our, let me pull it up. The area of our polygon is equal to 1/2 times 6.06 times 42. And once again, let's go back to our calculator. So we know, let's see, 1/2 is just another way of saying 0.5 times 6.06 times 42, and that's going to go ahead and give us 127.26, and in this case I believe we were using inches, so this would be inches squared. Now, just to really put this in context for you, what did we actually find here when finding the area? So let me go ahead and kind of erase all of this. And I want you to look back to where you drew in your notes. What shape were we given? Let's see, it had 6 sides. And anything with 6 sides, well, that's going to go ahead and give us a hexagon. That's right, a hexagon. And in this case, if you'll remember, all of these must be regular. So we know that all 6 sides are the same. Okay. And so what did our hexagon look like? Well, let's go back to that teal. We had our hexagon look something like this. And we know it had a side of 7 centimeters. And going back to our red, we know that our apothem, we found that to be 6.06. And really, and I guess I'm just going to kind of use this light little green here. What we found here was we found all of the space on the inside. So if you were to shade in this whole thing, how much space would it take up? Well, it would take up 127.26 square inches. I hope this helps, and good luck.